All right, now for some examples of finding the interval of convergence, uh, including finding the radius of convergence and testing the endpoints. But I think I'll leave these examples written in the notes, and I'm also going to do them on the chalkboard because I can fill in some extra small steps in the notes. They go pretty fast, so you can read through them in the notes or you can watch them worked out more slowly on the chalkboard. But let me go over the examples so you can see what to expect, and if you want, you can try them first. So you have summation n equals 1 to infinity x minus 3 to the n divided by n. So that is a power series. Just for examples, it has 3 instead of a. A was the constant, and this one has x minus 3. The rest of it is to the power n, which is always going to be there, and this one has 1 divided by n. That's the c sub n in the description above. The formula that has just a function of n in it, and it's multiplied by the power portion, which is the x minus a number to the n. All right, so as you can see there, and I'll do this on the board in a second, we're definitely going to use the ratio test. Notice it starts out with limit as n goes to infinity a sub n plus 1 over a sub n. That's just a reminder of the ratio test formula that we've been using for a couple of days now. Now, that a sub n plus 1 and a sub n, those are the entire term inside of the series that we're working on. It doesn't have anything to do with the a, which is minus 3 here. So it just means a reminder of how to plug in n plus 1 and then copy the original with just n and then take the limit as n goes to infinity. So then you find that limit. We're going to do it on the board, and then you have to check endpoints, which means we'll plug in the two endpoints. So we're going to find x equal to 2 and x equal to 4 are the endpoints. But then you plug those in for x back into the original series, n equals 1 to infinity 2 minus 3 to the n divided by n, and n equals 1 to infinity 4 minus 3 to the n divided by n. And that's what our answer is going to look like in this problem. It's going to be the closed interval from 2 to 4. Closed on the side of 2 and open on the side of 4, that is. And it's going to have a radius of convergence r equals 1. That's the distance on both sides of 3. It's like the radius of a circle, but this is just the radius of an interval from the middle to the endpoints. Then the next example is going to be one with n factorial in the denominator. So to compare this to the definitions above, it's as though we used a equals 0. Or you can just say x to the n is one of the kinds of power series that we'll see. There is no a here, or you could just say a is equal to 0 here. So you have x to the n, and the c sub n is the rest of the function that just has n in it. It's 1 divided by n factorial. Every single time we're going to use the ratio test on these. This one turns out to have an interval of convergence that goes from negative infinity to infinity, which in that case will mean that you don't need to check the endpoints. When the radius is infinity, you don't have to check the endpoints. They're just automatically left out because they're not really real numbers. So it's always the open interval from negative infinity to infinity, where you say for all x, real numbers. And then here's one which will be 5n x to the n. So again, a is equal to 0 here. and we'll just have x to the n. And c sub n is the formula 5n out front, multiplying the x to the n. And again, we'll use the ratio test, and then we'll check the endpoints. The answer to this one turns out to be open on both ends, -1 to 1. And then finally, one with a power 3 to the n times x to the n. That's going to be an interesting one. It has a equals 0 again, and 3 to the n as c sub n. And we're going to find that the radius of this one is 1/3. And we're going to be able to check both endpoints again. Oh, one more. 5n factorial x to the n. We'll look at this one as well. And it turns out that it only converges at x equal to 0. It only converges right in the center. It doesn't have any radius. Radius is equal to 0.